In this video, I'm about to show you 40 washing machine brands full of hidden problems and exactly why, along with 10 dependable options that are truly worth buying. Starting with number 40, Hotpoint. Hotpoint washing machines are popular because of their low price, but inside the cabinet, the engineering tells a very different story. Many models use older-style belt-driven motors that lose torque under heavy loads. This creates loud mechanical strain, long cycle times, and incomplete spins where clothes remain soaking wet. A major hidden issue is the design of the rear tub bearing. Hotpoint uses a small, low-grade bearing that begins to wobble when the drum is filled to maximum capacity. Over time, this wobble causes a grinding sound and eventually leads to water leaking into the motor housing. Another weak point is the plastic outer tub, which flexes during high spin. The flexing increases vibration, allowing the shocks to wear out faster than average. Control boards also fail due to low moisture protection, especially in humid laundry spaces. Detergent residue collects around the dispenser and flows into the electronics tray during rinse cycles. Although affordable, Hotpoint machines develop chronic vibration, weak spinning, bearing fatigue, moisture issues, and early motor wear, which makes them a risky long-term option. Number 39. Amana. Amana washers look simple and sturdy, but the internal construction has several structural weaknesses. Many models rely on a lightweight suspension system that cannot stabilize the drum when washing sheets or blankets. This causes aggressive shaking that slowly loosens the base frame and leads to out-of-balance shutdowns. Another issue is the direct drive motor's limited cooling path. When heavy cycles run back-to-back, heat accumulates around the stator and shortens motor life. The drain pump housing is made from thin plastic that cracks when exposed to small debris or coins, creating slow leaks that remain unnoticed until the floor becomes damp. The control panel uses inexpensive tactile switches that degrade with steam exposure and begin registering false inputs or delayed responses. Amana's tub design also invites detergent buildup, allowing mold to form around the rim and under the agitator area. While Amana seems like a basic, dependable machine, the unstable suspension, overheating motor, fragile pump, and weak moisture protection turn it into a maintenance-heavy appliance. Number 38. Insignia. Insignia washing machines are marketed as budget-friendly, but they use generic components that struggle with long-term reliability. The drum is mounted on a simplified single-piece spider arm that bends under repeated high-spin stress. Once the spider arm flexes, the drum becomes slightly off, which causes loud knocking and uneven wear on the bearings. Insignia control boards often fail due to minimal surge protection. Even small voltage fluctuations can damage the relay system and cause the washer to stop mid-cycle. The water level sensor is also inconsistent and sometimes misreads the load, filling either too little or too much water, which reduces wash quality. Insignia pumps are slow to clear lint and small debris and commonly clog, forcing the machine into repeated drain errors. Another issue is the thin metal used in the outer drum frame, which transfers vibration directly into the cabinet. This results in shaking and rattling even at moderate speeds. Insignia's low price comes at the cost of weak support components, inaccurate sensors, and long-term mechanical instability. Number 37. Haier. Haier washing machines appear compact and modern, but many models hide performance issues that show up after a few months of use. Haier uses lightweight stainless tubs that flex during high-spin cycles, causing repeated vibration spikes that wear down the suspension rods prematurely. The drain pump has a narrow impeller channel which easily clogs with lint, hair, or fabric threads. Once partially blocked, it causes slow draining, repeated pause errors, and eventually pump burnout. Haier's electronic boards use minimal waterproofing, which makes them vulnerable to moisture drifting upward from the detergent drawer. Over time, this leads to intermittent power failures or random cycle resets. Noise levels are also higher than expected because Haier machines rely on smaller motors that strain under heavy loads. When the motor heats up, the spin speed slows, and clothes remain damp. The gasket design around the door traps moisture in hidden folds, allowing mildew to grow even with regular cleaning. Haier machines can work well at first, but the pump clogs, electronic moisture issues, vibration spikes, and low-torque motor make them hard to depend on long-term. Number 36. Hisense. Hisense budget washing machines offer attractive pricing, but the internal build often struggles under regular household loads. Many units use a lightweight suspension rod system that cannot stabilize the drum once the tub fills. This causes repeated off-balance stops during spin and slowly loosens the inner frame. The drive motor is compact but tends to run hot because the cooling vents are positioned too close to the drain hose, causing warm moisture to recirculate into the motor area. Overheating shortens motor life and leads to sudden speed drops during heavy cycles. The drain pump also has a shallow housing that traps lint, leading to frequent drainage interruptions. Another hidden issue is the thin cabinet metal, which amplifies vibration and produces rattling noises as the washer ages. Moisture can seep behind the electronic panel due to a weak top seal, causing buttons to become unresponsive. Hisense machines seem modern on the outside, but the heat buildup, unstable suspension, and moisture-exposed electronics create long-term performance concerns. Number 35. TCL washing machines. TCL washers look sleek and modern, but their internal mechanics lack the durability seen in their televisions. The drum assembly is connected to a simplified two-point support system that cannot evenly distribute weight during large loads. This results in sudden banging noises and premature wear on the rear bearing. TCL uses a high-efficiency motor that produces good spin speed, but the motor controller is sensitive to power variations. Even small voltage dips can force the machine to restart the cycle or refuse to spin at full speed. The detergent drawer often clogs because the water jets are positioned too narrowly, leaving thick residue that drips into the cabinet. Over time, this leads to mold and a sour smell that is hard to remove. The drain pump also tends to vibrate loudly due to minimal insulation around its mount. TCL washers offer good features, but hidden issues with instability, detergent buildup, and power-sensitive electronics limit their reliability. Number 34. Midea washers. Midea produces many rebranded washing machines for other companies, and their own models share similar weaknesses. The drum uses a lightweight spider arm that bends slightly when overloaded. Once bent, the drum loses alignment and begins rubbing against the outer tub wall during spin, creating scraping sounds. The water inlet valve has small internal screens that clog easily when exposed to mineral-heavy tap water, causing slow filling and repeated error codes. The recirculation system is also weak and struggles to move water evenly across the load, reducing cleaning effectiveness. Midea control boards are known for early capacitor wear, which can cause the machine to power cycle or freeze on the same minute marker. The drain hose kinks easily because it is thin and flexible, leading to partial drainage and wet clothing at the end of cycles. Although Midea washers are widely available, their alignment issues, slow fill valves, and electronic instability create ongoing maintenance challenges. Number 33. Magic Chef. Magic Chef washing machines are designed as compact, apartment-friendly options, but their smaller size leads to several functional compromises. The inner tub is supported by a compact suspension system that cannot handle dynamic loads like blankets or jeans, leading to severe shaking that travels into the floor. The motor is undersized and often fails to maintain spin speeds when the load absorbs excess water. This leaves clothes damp and increases drying time. Magic Chef uses a narrow pump impeller that clogs quickly with lint or pet hair, forcing the user to clear the filter far more often than other brands do manually. The control panel is sensitive to humidity because the backing seal is thin, and steam from hot washes can creep behind the buttons. The cabinet metal is also very thin and dense easily, which eventually disrupts drum clearance and causes rubbing noises. Magic Chef machines may suit very light loads, but their weak suspension, slow drainage, and moisture-sensitive electronics limit long-term use. Number 32. Danby washers. Danby washers are compact units aimed at small spaces, yet the internal mechanical design has clear limitations. The drum assembly uses minimal insulation, allowing vibration to transfer directly into the cabinet. This makes Danby washers noticeably louder than similar-sized competitors. The drain pump relies on a small impeller that struggles when the load includes towels or thick fabrics. Partial clogs create slow, draining, and cycle interruptions. The motor is positioned close to the tub without adequate splash protection, allowing stray moisture to accumulate around the wiring harness. Over time, this leads to corrosion and intermittent operation. The lid switch mechanism is also a frequent failure point, because the plastic actuator wears down quickly, causing the machine to stop mid-cycle even though the lid is closed. Danby washers remain popular for tight spaces, but the vibration transfer, pump delays, and moisture-exposed motor area make them unreliable over extended use. Number 31. Galan's washers. Galan's washers use lightweight plastic outer tubs that flex significantly during spin. As the tub flexes, the drum position shifts, and the machine begins thumping loudly whenever the load becomes uneven. This repetitive impact shortens the life of the bearings and strains the suspension rods. Gallant uses a small direct drive motor that delivers fast spins but lacks the torque needed for heavy loads. When overloaded, the motor overheats and triggers a protective slowdown that leaves clothes wetter than expected. The detergent drawer has a design flaw where water splashes backwards into the cabinet during dispensing, creating hidden moisture pockets that lead to mildew and foul smells. The control board uses low-grade solder joints that crack under vibration, causing random cycle resets. Although marketed as efficient and user-friendly, Gallant's washers suffer from tub flex, low torque motor performance, and moisture-driven electronic instability. Number 30. Black plus Decker compact washers. Black plus Decker compact washers are popular for dorms, apartments, and RVs, but they face structural and mechanical shortcomings. The small drum capacity forces the motor to work harder with even modest loads. This causes the drive system to overheat during back-to-back cycles. The suspension rods are short and stiff, which makes the washer prone to jumping or sliding across smooth floors during high spin. The drain pump is weak and uses a tiny impeller chamber that clogs quickly with lint or detergent lumps. The control board has minimal surge protection and tends to malfunction if connected to unstable power sources. The plastic outer tub is thin and can warp under heat or heavy loads, leading to scraping sounds as the drum rotates. Black plus Decker compact washers are convenient for small spaces, but their limited capacity, heat strain, and fragile tub material reduce long-term durability. Number 29. RCA washers. Various contract manufacturers produce RCA washers and often lack consistent internal build quality. The drum uses a basic bearing system that offers little protection against water intrusion. As moisture enters the bearing housing, rust forms and leads to grinding during spin cycles. RCA machines have a tendency to run out of balance because the suspension uses simple coil springs without adequate damping. When the drum shifts off center, it creates severe vibration and causes the washer to shut down mid-cycle. The drain pump is loud and prone to early wear because the mounting plate transfers vibration directly into the pump body. RCA control panels are known to freeze when humidity builds around the buttons due to poor sealing. The lid hinge assembly is also fragile and can loosen after repeated use, misaligning the safety switch. RCA washers may appear affordable, but the moisture-sensitive bearings, unstable suspension, and inconsistent electronic sealing make them unreliable choices. Number 28. Frigidaire Budget Line. Frigidaire's budget washing machines look sturdy, but internally they use a simplified mechanical layout that causes long-term wear. The outer drum is made from a thinner composite that flexes during spin, slowly pushing the rear bearing out of alignment. Once misaligned, the machine develops a deep rumbling sound that gets louder with every load. The drive belt also sits close to an exposed pulley edge, which sheds fine rubber dust over time, eventually making the belt slip and produce a burning smell. Frigidaire's budget control boards use basic triacs that heat up during extended cycles, leading to mid-cycle pauses or unresponsive buttons. The water inlet valves clog easily because the internal filters are extremely fine and trap even mild mineral sediment. Another hidden weakness is the detergent dispenser, which is placed above a warm airflow pocket that never fully dries and quickly grows mildew. Frigidaire's economy models may be affordable, but the belt shedding, drum flex, valve clogs, and overheated controls create costly maintenance later. Number 27. GE older budget models. Older budget GE washers are known for long-lasting frames, but the mechanical parts inside have several weaknesses that show up after years of use. These models often use an aging transmission design that struggles when switching from wash to spin, producing a loud clunk followed by delayed agitation. The tub seal at the bottom of the drum hardens over time and begins allowing small amounts of water to enter the bearing chamber. Once moisture reaches the bearing, rust forms and grinding noises start. The motor relay on older GE control boards is also prone to arcing because of minimal shielding, causing the washer to shut off randomly. The pump design uses a tall, narrow channel that becomes noisy as soon as lint gathers at the base. The suspension system depends on friction pads that wear smoothly, reducing stabilization and causing shaking even with small loads. These GE models were well known in the past, but hidden transmission strain, moisture intrusion, and worn pads make them unreliable today. Number 26. Whirlpool older budget models. Whirlpool's older, low-tier washers may look dependable, but several internal designs limit their reliability. The direct drive coupling, a small plastic and rubber connector between the motor and transmission, wears out quickly when the washer handles heavy or unbalanced loads. As it deteriorates, the machine starts clicking, then eventually stops spinning entirely. The outer tub uses stiff mounting points that transfer vibrations straight into the cabinet, creating loud rattling which worsens as the machine ages. The inlet valve gaskets also stiffen with heat cycles, leading to small leaks that drip onto the wiring harness. Once moisture reaches Whirlpool's older connectors, corrosion begins and the washer may refuse to start or frequently display error codes. The pump impeller sits low and picks up small objects like coins or threads, which can jam it easily. Older Whirlpool budget units were easy to repair, but the weak coupling, stiff tub mounts, gasket failures, and corrosion-prone wiring create repeat problems over time. Number 25. Kenmore. Kenmore washers come from multiple OEM manufacturers, and this inconsistency creates unpredictable reliability issues. Some models use a Whirlpool-style drive system, while others borrow Samsung or LG designs, but with cheaper internal components. The result is a mix of parts not originally engineered to work together. On several models, the motor control board overheats because the ventilation slots do not match the airflow needs of the borrowed motor. Other versions have transmission assemblies that wear unevenly because the tub and agitator are sourced from different suppliers. Drain pumps vary widely in quality, and weaker versions often buzz loudly or seize after minor obstructions. Kenmore machines with rebranded log-style drums may suffer from spider arm corrosion due to lower-grade alloys. Users frequently struggle to find the correct replacement parts because the internal components do not match the brand label. Kenmore's main issue is not poor engineering from one source, but unpredictable OEM mixing, which leads to mismatched components and inconsistent failure patterns. Number 24. Sharp washers. Sharp washing machines outside Japan often come from third-party manufacturers and carry several hidden weaknesses. The tub uses a lightweight metal frame that bends slightly during high spin. This microflexing creates repeated stress on the drum shaft, eventually loosening it and causing off-center spinning. The control panel has a sleek surface, but underneath it relies on a thin ribbon cable that becomes brittle with heat and begins losing contact, causing random beeping or unresponsive controls. The drain pump uses a shallow impeller pocket that traps hair and lint, producing a loud grinding noise before it stalls. Sharp's imported washers also struggle with water temperature regulation because the heating sensor is positioned too far from the water flow, leading to inaccurate readings and cycle delays. While the brand name is respected, these outsourced models suffer from flexing drum mounts, fragile ribbon cables, unreliable pump design, and inconsistent temperature sensing. Number 23. Panasonic washers. Panasonic's premium washers are excellent, but low-tier imported models sold in select markets use stripped-down components that reduce long-term reliability. The drum bearings are smaller than industry-standard sizes and begin to whine earlier than expected. Their motor runs quietly at first, but struggles under heavy loads because the torque curve is flatter than that of higher-end Panasonic units. When overloaded, the motor controller heats up, causing slow spin speeds and damp laundry. The detergent tray design sprays water unevenly, leaving residue that accumulates and forms black mold inside the drawer cavity. The tub gasket has a narrow lip that traps moisture and develops a musty smell even with regular cleaning. The drainage system uses a compact pump that cannot sustain heavy lint flow, causing frequent drain interruptions. These budget imports look polished, but the undersized bearings, weak motor torque, uneven detergent rinsing, and narrow gasket design create persistent maintenance problems. Number 22. Avanti compact washers. Avanti compact washers are convenient for small apartments, but their small size forces several compromises. The drum has a limited capacity, which causes constant imbalance when washing mixed fabrics. The suspension rods are short and stiff, transferring vibration directly into the cabinet and making the machine jump during high spin cycles. The motor ventilation is minimal because the motor sits close to the tub, causing heat buildup that shortens motor life. The pump uses a tiny impeller that cannot handle lint-heavy loads, resulting in slow draining and repeated error codes. Avanti's control boards are also prone to moisture exposure because the top panel does not have a strong seal. Over time, the humidity reaches the electronics and leads to intermittent failures. The detergent dispenser is shallow and does not flush properly, leaving residue that clumps and affects wash quality. Although compact and convenient, Avanti washers suffer from imbalance issues, weak heat control, moisture-sensitive electronics, and incomplete drainage. Number 21. Giantex portable washers. Giantex portable washers are lightweight and easy to move, but their internal design introduces several long-term issues. The drum is supported by a very simple suspension system that cannot manage shifting loads. Even a small imbalance causes the entire unit to hop across the floor. The motor is compact but lacks proper cooling, especially during repeated cycles, which leads to slow spin speeds and overheating shutdowns. The drain pump is basic and uses a narrow outlet path that traps lint and fabric threads, causing repeated drainage delays. Giantex also uses thin plastic for the outer tub, which becomes slightly oval with age, creating rubbing noises between the drum and the tub wall. The timer-based control system lacks precise regulation and can pause unexpectedly due to weak electrical contacts. These washers are handy for temporary use, but the weak suspension, limited motor cooling, and fragile tub material make them unreliable for daily laundry needs. Number 20. Costway Portable Washers. Costway washers are budget-friendly but contain several engineering shortcuts. The internal tub is mounted with a 2-point support that struggles to keep balance during heavier loads. This leads to sudden knocking sounds and frequent cycle interruptions. The motor is designed for low power draw and cannot sustain long spin cycles without overheating. Once hot, the machine reduces spin speed automatically and leaves clothes wetter than expected. The drain system relies on gravity and a small pump that quickly clogs when lint accumulates. Costway's control dials use basic mechanical timers with inexpensive springs that wear out and create inaccurate cycle durations. The thin plastic cabinet easily warps when exposed to heat or pressure, which eventually misaligns the drum. Costway units are convenient for light laundry, but their motor strain, inaccurate timers, and weak structural support limit their lifespan. Number 19. Comfy washers. Comfy washers are popular in apartments and dorms, but the internal build reveals several hidden problems. The drum assembly uses a slim bearing system that starts to whine when overloaded. If the bearing loosens even slightly, the drum wobbles and puts additional pressure on the motor shaft. The motor itself is compact, but tends to run at inconsistent speeds because the controller struggles to maintain torque during full loads. The detergent tray often leaves residue because the spray channel is narrow and does not flush properly during rinse. The drainage design includes a low-position pump that easily traps small objects and becomes noisy before failing. Comfy control panels also suffer from moisture exposure because the top cover seal allows steam to enter during hot washes. This causes buttons to become unresponsive over time. While convenient, comfy washers face bearing instability, pump sensitivity, and moisture-prone electronics. Number 18. Panda Portable Washers. Panda portable washers are popular for tight spaces, yet their lightweight construction brings multiple complications. The internal drum is small but spins at a relatively high speed, causing noticeable vibration due to minimal counterbalance weight. The motor struggles when loads absorb too much water, leading to uneven spinning and extended drying time. Panda uses a simple water inlet valve that clogs when exposed to mineral-rich tap water, slowing filling significantly. The pump and hose system is also prone to kinking and blockages, especially when the unit is placed in confined areas. The cabinet material is thin and becomes noisy as internal components loosen with age. The mechanical timer uses basic gears that can slip if the unit shakes excessively. Panda washers are easy to set up, but the combination of vibration, slow filling, and mechanical wear makes them better suited for light, occasional use. Number 17. Summit Appliance Washers. Summit washers come in compact and mid-sized versions, but both rely on parts sourced from multiple factories, leading to inconsistent reliability. Some models use a weak belt tension system that loosens after repeated cycles, causing the drum to spin slowly or not at all. Others include a fragile pump mount that vibrates heavily and begins to leak where the pump meets the housing. The electronic boards vary by supplier and often lack uniform moisture protection. This leads to intermittent sensor readings and unexpected cycle resets. The drum bearings are lightly greased and begin to hum earlier than expected, especially in harder water regions. Summit washers also suffer from inaccurate water level sensing because their pressure switch tubing is placed too close to the drum, allowing splashes to interfere with readings. While Summit offers variety, the mixed components, weak belt tension, and unstable pump design produce unpredictable performance. Number 16. Zline Appliance Washers. Zline washers have a premium exterior, but internal inspection reveals several compromises. The drum is attached to a stiff support frame that transmits vibration directly into the cabinet, creating a loud drumming sound during high spin. The motor is powerful but draws significant current, and the control board's heat management is minimal. During long cycles, the board heats up and begins slowing the spin rate to protect itself. The detergent drawer sits above a warm airflow channel, which prevents it from drying and leads to soap residue buildup and mold. Zline washers also feature a pump that relies on a slim impeller design, which easily jams when small debris enters. The water inlet valve uses an undersized solenoid that wears out quickly in homes with fluctuating water pressure. Although they appear high-end, Z-line washers face vibration transfer, heat stress control boards, and limited pump durability. Number 15. Crosley washers. Crosley washers look simple and sturdy, but their hidden issue sits inside the transmission system. Crosley uses an older-style gear case that relies on thick mechanical oil to keep the agitator synchronized. With repeated hot water cycles, the oil thins and the agitator begins slipping one notch at a time. Users usually notice this as clothes bunching in the center or long wash times with very little turnover. The clutch plate inside the gear case also loses friction because Crosley uses a softer metal alloy to keep costs down. As the clutch weakens, the drum hesitates before spinning, placing heavy stress on the belt and motor shaft. Crosley's water level switch is mounted low on the frame, allowing vibration to disturb the pressure readings. This causes the washer to overfill on some cycles and underfill on others. The machine feels basic and dependable, but its aging gear case design, soft clutch, and unstable water level sensing create hidden reliability issues that grow worse with time. Number 14. Speed Queen. Speed Queen has a strong reputation today, but the older commercial-style problematic line had a specific internal flaw rarely discussed. Those models used a stiff vertical axis suspension with almost no lateral damping. When load shifted, the tub's steel support welds took the full shock without any distribution. Over years of use, microcracks formed at the weld points where the tub met the support spider. These cracks didn't appear externally, but caused sudden bang noises during spin cycles, followed by slight tub wobble. The bearings in these older units were also sealed with a thin, single-lip seal that allowed moisture seepage when users ran too many hot cycles. Eventually, the bearing grease thinned, and the spin shaft began grinding. The result was a loud, roaring noise that often forced full machine replacement. While newer Speed Queen units corrected these issues, the old commercial line struggled with weld stress, single-lip bearing seals, and rigid suspension geometry that magnified long-term wear. Number 13. Equator Combo Washers. Equator Combo units save space, but suffer from a unique dual-mode engineering flaw. The drying section uses a condensing system that relies on stable airflow, yet the washer's internal ducts are extremely narrow. As lint and moisture collect, airflow is restricted, causing the heating element to run hotter than designed. The excess heat radiates toward the control board, slowly degrading the triacs that regulate motor speed. Over time, users notice irregular spin RPM or random cycle stops. Equator also uses a compact inverter motor that demands precise calibration, but the machine's vibration during drying cycles causes the calibration sensors to drift. This leads to the drum reversing unexpectedly or failing to ramp up to full spin. Another hidden problem is moisture migration into the detergent drawer compartment, which causes mild electrical noise near the selector knob. Number 12. Thor kitchen washers. Thor kitchen washers offer a heavy stainless exterior, but internally they rely on a simplified pump-to-drain routing system with almost no backflow protection. When users install the unit slightly lower than the drain outlet, gray water can siphon back into the tub between cycles. This makes clothes smell damp even when freshly washed. Thor also uses a stiff belt tensioner that over-tightens as humidity changes, placing excessive torque on the motor during startup. The motor controller compensates by sending a higher current burst, which heats the MOSFETs on the board. With repeated cycles, the MOSFETs lose sensitivity, and the spin curve becomes uneven. The washer's cabinet also resonates strongly at mid-speed spin because the counterweight is made of molded cement with small voids. These voids create an imbalance when the weight ages or chips. Thor's solid look hides drainage backflow risk, torque spikes, and inconsistent spin stabilization that limit long-term reliability. Number 11. Winia. Winia washers share roots with older Daewoo engineering, and their unique flaw lies in the pulsator drive system. The bottom pulsator plate is connected through a magnetic clutch that depends on a clean magnetic field to shift between wash and spin modes. But the clutch chamber is placed very close to the drain path, where fine sediment and detergent residue accumulate. Over months of use, residue disrupts the magnetic field, causing delayed or incomplete clutch engagement. Users experience half-spin cycles or abrupt thumping when the clutch slips under load. The water inlet valves also respond poorly to fluctuating household pressure, causing inconsistent rinse levels. Additionally, Winia's circuit boards are mounted vertically with minimal conformal coating, allowing humidity from hot washes to oxidize solder points. The washer works smoothly at first, but magnetic clutch contamination and moisture-prone electronics slowly degrade performance. Number 10. Sansui washers. Sansui washers appear simple but contain a unique imbalance between drum geometry and motor torque. Sansui uses a drum with unusually steep rib angles, designed to lift clothes aggressively. However, the small motor struggles to match this lift pattern at higher water levels. When the drum tries to raise too much weight, the torque drops sharply, causing micro-stalling during wash strokes. These tiny stalls produce an uneven rhythm that strains the drive belt and creates long-term slippage. The pump design is also unconventional. The impeller is housed in a shallow cavity that easily develops air pockets, especially when draining at low water pressure. Air pockets cause intermittent sucking noises and slow drainage. Sansui's lid switch also wears quickly because it uses a soft leaf spring that bends out of alignment. Although the washer looks uncomplicated, the mismatched rib geometry, motor torque dips, and air-locking pump create recurring problems. Number 9. Super Deal Portable Washers. Super Deal portable units are extremely lightweight, but that weight reduction comes from using a drum support column made of hollow plastic. Under repeated spinning, the column flexes slightly, causing the drum's rotation angle to change by a few degrees. This misalignment places diagonal stress on the motor coupler, which begins to crack along its edges. Once weakened, the coupler transmits torque inconsistently, producing a stop-start spin motion. The spin basket also relies on a loosely fitted mesh sleeve that traps lint behind the plastic lining, restricting water flow during spin. Over time, the mesh bulges and scrapes against the drum wall, creating a squeaking sound. The drain hose has very little internal reinforcement, so warm water softens it and causes kinks. Super Deal washers save space and money, but their hollow drum support, fragile coupler, and soft hose construction lead to accelerated wear. Number 8. Extreme Power US Washers. Extreme Power US washers look versatile, but their biggest hidden issue lies in the way the drive shaft connects to the lower transmission plate. The shaft is supported by a thin polymer bushing instead of a metal bearing. Repeated wash cycles, heat, and vibrations soften this bushing, causing the shaft to tilt a few degrees during agitation. Once it leans, the pulsator strokes unevenly and the lower plate grinds against its housing, creating a faint scraping noise that grows louder over time. The water pump is also mounted at a diagonal, which traps small pockets of air whenever the machine is filled quickly. This delays draining and forces the motor to work harder during spin startup. Extreme Power US uses a lightweight plastic tub ring that flexes during high spin, allowing minor tub wobble that further accelerates shaft wear. The washer feels handy at first, but the plastic bushing, tilted shaft motion, and diagonal pump setup gradually reduce performance and reliability. Number 7. Coolmore washers. Coolmore washers appear premium with a stainless exterior, yet their internal wash chamber features a narrow water channel on the left side of the tub. This channel controls recirculation flow, but the opening is too small and traps fabric lint during heavy cycles. As lint builds up, the recirculation jet weakens and creates uneven washing, where one side of the drum receives more water flow than the other. The imbalance eventually strains the direct drive motor, especially when the drum fills with soaked fabrics that settle unevenly. Coolmore also uses a low-profile damper system attached to thin metal brackets. These brackets bend slightly when exposed to vibration, creating a small gap that causes the drum to oscillate at mid-speed. The control board has tightly packed heating resistors placed near the power relay. During long cycles, heat from both components accumulates and leads to random pause events. Coolmore's sleek design hides issues with restricted recirculation, bending brackets, and heat clustering on the board. Number 6. Amrelieve Mini Washers. Amrelieve Mini Washers are compact, but their internal mechanics show a unique weakness in the pulsator spline. The spline teeth are molded from soft plastic and engage loosely with the motor coupler. When heavier items like towels or jeans are washed, the pulsator slips briefly before catching again. This intermittent slipping produces a clicking sound and creates an inconsistent wash rhythm that reduces cleaning efficiency. Amrelieve also uses a simple auto-drain valve with a floating plug. When water is soapy or contains residue, the plug sticks and delays the start of draining, causing the machine to stall mid-cycle. The tub walls are made from thin, multi-layer plastic that flexes noticeably during spin, raising friction where the drum rim brushes the inner housing. Over time, this friction produces a dull buzzing sound and increases motor strain. Amerlev units fit small spaces, but their soft spline, sticky drain plug, and flexible tub material shorten lifespan significantly. Number 5. HomeLabs washers. HomeLabs washers have a modern control panel, yet the internal drive system reveals a distinctive flaw. The motor uses a two-phase torque curve programmed for quick acceleration, but the drum support ring does not stabilize the inner tub quickly enough. As a result, the drum jolts forward slightly at the start of each spin cycle. These micro-jolts gradually loosen the bolts that secure the drum spider arms. Once loose, the arms shift under load and cause mild banging noises during heavy cycles. HomeLabs also relies on an air pressure sensor positioned in a tight cavity near the tub. When steam builds during hot washes, condensation forms inside the sensor tube and temporarily disturbs the pressure reading, which leads to incorrect water levels or sudden cycle skips. The drain pump uses a rigid housing that amplifies vibration, making it louder over time. HomeLabs washers appear refined, but spin jolting, loose spider arms, and moisture-sensitive pressure sensing reduce overall reliability. Number 4. Best Choice Products washers. Best Choice Products washers are lightweight, but depend on a very simple belt routing design with no automatic tension adjustment. As the belt stretches naturally with use, the drum begins slipping during agitation. Users notice sluggish wash motion long before the belt visibly wears out. The pump assembly also includes a narrow internal flap that prevents backflow, yet this flap stiffens when exposed to detergent residue. Once stiff, it restricts water movement and slows draining, leaving clothes wetter. The machine's outer cabinet is made from thin plastic sections fused using heat, but the seams occasionally warp under warm wash cycles. This creates a slight frame distortion that misaligns the drum and produces a rubbing hum. The lid hinge is mounted with small screws that loosen easily because the top panel flexes during spin. Best Choice Products washers handle small loads conveniently, but their stretching belt, stiff backflow flap, and distorted cabinet seams limit durability. Number 3. Rovsun Compact Washers. Rovsun Compact Washers are designed for tight spaces, yet they contain a particular weakness in their wash-spin switching system. The internal selector uses a rotating cam that shifts between agitation and spinning, but the cam is made from brittle composite material. Under repeated stress, it develops tiny surface fractures and fails to lock fully into position. Users experience half-strength spinning or delayed switching between modes. The drain pump is mounted close to a warm section of the chassis, causing its internal seals to soften. Once softened, the pump becomes noisy and loses pressure. Rovsun also uses a loosely fitted inner basket that spins inside a minimal support ring. If the machine is placed on uneven flooring, the slight tilt causes the basket to lean toward one side, leading to uneven spin force. The machine appears versatile, but the fragile selector cam, softened pump seals, and tilted basket support create long-term issues. Number 2. Costway Twin Tub Washers. Costway twin tub washers offer washing and spinning together, but the twin tub design introduces an unusual mechanical challenge. The spin tub uses a lightweight aluminium spindle attached to a plastic base that flexes under weight. This flexing causes the spindle to shift slightly off-center when heavier fabrics are spun. Once off-center, the tub vibrates strongly even with modest loads. The wash tub uses a basic mechanical agitator driven by a small belt that heats quickly and loses friction, especially during long cycles. The internal divider between the two tubs also collects lint and moisture, which leads to mildew odor and occasional water seepage. The water drain for the spinner passes through a narrow hose that kinks easily, delaying drainage and stressing the pump. While Costway twin tubs look convenient, the bending spindle, heating belt, and moisture-trapping divider create recurring reliability issues. Number 1. Blackmagic Portable Washers. Blackmagic portable washers have a catchy name, yet their internal engineering shows a rare but serious flaw in the motor capacitor system. The capacitor responsible for starting the motor is undersized and heats rapidly during extended wash cycles. As the capacitor warms, its capacitance drops, causing the motor to begin weakly or stall momentarily. Users often feel the drum jerking when this happens. The cabinet is ultralight and uses hollow tubing under the base, which flexes slightly during spin. This flex causes the entire unit to lean forward and shift weight unevenly onto the front supports. Over time, this misalignment bends the motor bracket and alters the belt angle. The drain hose also relies on soft plastic that hardens with age and forms micro cracks. The washer looks convenient, but its undersized capacitor, leaning base frame, and aging drain hose make long-term performance inconsistent. But don't worry, it's not all bad news. Some washing machine brands are actually reliable, durable, and built to last. They may not be the trendiest models, but they're the ones you can trust without stress, starting with number 10. Miele. Miele washers stand out because their internal engineering is built around long-term stability rather than cost-cutting. The drum rides on a heavy-duty cast spider with reinforced arms that resist fatigue even after thousands of cycles. Their Profi Eco motor uses magnetic regulation that maintains torque without overheating or vibrating, which helps the washer run quietly at high spin speeds. The honeycomb drum pattern reduces textile abrasion and prevents fiber snagging, improving fabric lifespan. Miele seals the control board inside a moisture-protected compartment, preventing steam damage that affects many budget models. The water flow system includes a self-cleaning overflow channel that keeps detergent buildup from entering the pressure sensor tubing. These details create predictable wash performance and extremely low failure rates. For households wanting dependable mechanics and stable electronics, Miele washers consistently deliver clean laundry without hidden durability issues. Number 9. Bosch. Bosch washers earn trust because their precision balancing system reduces load stress from the moment the spin cycle begins. Instead of relying on heavy concrete weights alone, Bosch uses dynamic software-based load mapping that adjusts rotation based on sensor feedback. This keeps vibration low and protects bearings from excessive strain. Their Eco-Silence motor uses a brushless design that prevents carbon dust contamination inside the drum cavity. Bosch inlet valves include a fine mesh that resists mineral blockage and improves long-term water flow consistency. The detergent tray has a bypass rinse channel that prevents mold buildup and keeps the drawer fresh between cycles. The stainless steel drum uses evenly spaced perforations that promote efficient draining without stressing the pump. Bosch washers combine gentle mechanical handling with stable electronics, making them a strong, low-risk choice for everyday laundry. Number 8. LG Inverter Direct Drive Premium Line. LG's premium direct drive washers stay reliable because their entire drivetrain is simplified around a motor that connects directly to the drum hub. This design removes belts and pulleys that commonly stretch or slip in regular machines, keeping torque delivery stable even under heavy loads. The inverter system regulates motor speed smoothly so the drum doesn't jolt at the start of agitation or spin, which reduces long-term stress on bearings. LG's 6-motion programming varies drum movement patterns to prevent fabric tangling and minimize vibration. Their pressure sensor includes a self-clearing design that expels moisture during each cycle, helping water level readings stay accurate. The stainless steel drum and reinforced hub resist corrosion and maintain alignment through years of use. LG also uses a debris shield to protect the pump impeller from lint buildup. These features combine to deliver steady washing performance with minimal wear and consistent energy efficiency. Number 7. Samsung Bespoke and Premium Lines. Samsung's premium bespoke washers use a well-designed vibration reduction system that stabilizes the drum even during high RPM cycles. The system distributes the tub mass uniformly so the bearings experience minimal lateral force. Their digital inverter motors maintain speed without generating excess heat, extending electronic component life. Samsung's internal spray system keeps detergent dissolved evenly and prevents thick residue from reaching the pump. The control board is coated with moisture-resistant resin that guards against steam exposure. Water routing inside the drum cavity uses wide channels that resist clogging. The glass lid and frame are reinforced to prevent play during spin cycles. This combination of controlled vibration, efficient water flow, and heat-stable electronics makes Samsung a safe choice for households wanting smooth performance and long-term reliability. Number 6. Electrolux front-load washers. Electrolux front-load washers are known for dependable performance because their internal wash mechanics are designed to keep stress off the drum and motor. The drum uses a smooth wave pattern that lifts fabrics gently while maintaining strong turnover, reducing strain on the suspension. Their Smart Boost system premixes detergent with water before it enters the tub, preventing chemical residue from reaching the pump and improving fabric rinsing. Electrolux pairs the drum with oil-filled dampers that stay stable under shifting loads, allowing the machine to spin at high speeds without shaking. The drain pump has a wide impeller chamber that moves water efficiently and handles lint without frequent clogging. The electronic controls sit inside a moisture-protected enclosure that shields the board from steam during hot cycles. Water inlets are reinforced to maintain steady pressure. These combined details help Electrolux washers stay reliable, balanced, and effective for daily family use. Number 5. Fisher and Paykel Wash Smart Series. Fisher and Paykel's Wash Smart washers earn their dependable reputation through a design that keeps mechanical load and water movement carefully controlled. Their direct drive motor operates with a smooth torque curve, preventing the sudden surges that strain suspension components in many top-load machines. The drum uses a gentle lifting profile that circulates fabrics evenly, which reduces tangling and allows the motor to maintain efficiency throughout the cycle. Load sensing software adjusts water levels with precision so the machine never forces the motor to work harder than necessary. The pump is engineered with wide internal pathways that handle lint without quickly slowing down. Fisher and Paykel also isolate their control electronics away from the humid upper chamber, protecting the board from condensation produced during warm wash cycles. With stable water management, balanced motion, and a simple but durable drivetrain, the Wash Smart series provides long-term reliability for everyday heavy laundry use. Number 4. GE Ultra Fresh and Premium Series. GE's Ultra Fresh and Premium washers stand out because their internal design focuses on moisture control and mechanical balance rather than cosmetic upgrades. The Ultra Fresh venting system circulates air through the drum cavity after each cycle, preventing the trapped humidity that normally leads to odor, mold, and sensor interference. The stainless steel drum is engineered with an even weight distribution pattern, helping the bearings maintain alignment during high-speed spins. GE's inverter motor delivers smooth torque transitions that reduce stress on the suspension system. Their drain pump uses a coated housing that resists mineral accumulation and maintains steady flow through extended use. The control board sits behind a sealed compartment that shields the circuitry from steam. Inlet valves are reinforced to handle variable household pressure without leaking. These washers perform consistently, stay dry between loads, and maintain stable spin mechanics, which makes the GE Premium line a safe and durable long-term choice. Number 3. Whirlpool Premium Load and Go line. Whirlpool's Premium Load and Go washers are dependable because their mechanical layout is built for consistent performance under frequent use. The drum sits on a well-balanced support system that stabilizes movement from the moment spin begins, preventing wobble that can stress bearings. Their Load and Go dispenser releases measured amounts of detergent so the pump seals and hoses aren't exposed to heavy residue, which helps maintain strong water flow over time. The motor uses insulated windings designed to run at controlled temperatures, allowing smooth torque delivery even with large loads. Whirlpool's drain channels are engineered wider than those found in standard models, reducing the chance of lint collection and shortening rinse times. The pressure sensor is positioned away from the steamy upper chamber, helping it maintain accurate readings through years of use. Combined with a durable inlet system and sturdy cabinet frame, this line stays reliable and steady across demanding laundry cycles. Number 2. Maytag Premium Line. Maytag's premium washers are trusted because their internal design focuses on mechanical stability rather than lightweight shortcuts. The brand uses a high-torque, commercial-grade motor that maintains consistent speed during heavy loads without overheating. Their stainless steel drum sits on a reinforced support ring that resists flexing, which keeps the bearings aligned and reduces long-term vibration. Maytag also employs a dual spring suspension that absorbs sudden movement when the drum shifts during large cycles. The water inlet system has a wide flow path that prevents mineral buildup and keeps filling pressure steady. Their control board is coated with insulating resin that protects circuits from humidity, especially during long, hot washes. The pump design includes a durable impeller that moves water efficiently without straining. Together, these features create a dependable washer that handles frequent use with stable performance and minimal wear over time. Number 1. ASCO Front Load Washers. ASCO washers are engineered with Scandinavian durability principles. The drum is supported by a full steel tub rather than plastic, reducing long-term warping and improving vibration control. Their Quattro suspension system uses 4 shock absorbers that isolate the drum from the cabinet, keeping spin cycles stable. The motor runs at controlled temperature levels and supports long washing sessions without strain. ASCO's pump is designed for high water volume and resists clogging. The electronic components are placed in a sealed section, separated from humid areas. ASCO washers are known for quiet operation, reliable mechanics, and long service life, making them a premium, safe choice.